Acidity of substituted aromatic compounds. Okay, right. Now in this class we will study about acidity of substituted aromatic compounds. Okay, right. So you see here we studied about acidity. That's why you take acids which are present, COH group is present on benzene ring. Okay, one by one we can study it. First we can take an example on benzene ring. On benzene ring COOH, it is benzoic acid. Now we can take OH group. So that is hydroxy group. Hydroxy group can be present as substitution on benzoic acid. So it is one orthohydroxy benzoic acid. And second example, metahydroxy benzoic acid. And we take a third one, parahydroxy benzoic acid. Okay, now we can compare acidity of these four groups. Okay, so when you compare these groups, you see COOH, it is common, that is benzoic acid. Now we can see the substituent OH, OH, OH. Okay, here it is presented ortho, meta, para. Okay, right. So while explaining about acidity of benzoic acids, here one effect is present, that is called ortho effect. Due to having ortho effect, okay, that group which is present on ortho position, either electron donating or electron withdrawing group, here if it is present at ortho position, that is having highest acidity character. Okay, so it is first one, 2, 3, 4. Okay, in these four, if you want to write acidity order, so in this, if you write acidity order, irrespective of the group, ortho group is more acidic nature. Due to ortho effect, ortho is more acidic nature. Here it is a plus IE group or minus IE group, electron donating group or electron withdrawing group, any group it is present, it's having more acidic nature. Okay, right, it is due to ortho effect. Right, now in remaining these, you see OH, meta position, para position. Whenever OH is present at meta position, it's having minus I nature. Okay, that means here OH can be act as minus IE group. Okay, so minus IE group means it is electron withdrawing nature, it's having electron withdrawing nature. Right, whenever it is present at para position, it's having minus IE nature. Addition to this, plus resonance nature, Bejovic effect is also present. Okay, here electron withdrawing nature is present, electron donating nature is present. Minus is withdrawing, plus is donating. Two types of groups are present. In between these two, when you take net charge, it having donation, electron donation. Okay, here it having electron withdrawing and it's having electron donation. Okay, so whenever we explain about acidity of carboxylic acid, generally electron withdrawing groups can increases the acidity. Okay, so the compound which contains electron withdrawing group, that can increase the acidity. Okay, so when you compare meta and para, in these two, meta is more acidic. Okay, so here when you compare these two, in these two, which we have to taken as more acidic, meta we have to taken as more acidic. Okay, that's why we take like this. So meta. After this, here you see remaining, it is standard condition. Here group is not present. Here one group is present, it having electron donating group, but it is what standard and neither electron withdrawing nor electron donating. So whenever you see standard condition and electron donating capacity, in this standard having more acidic nature. So this is the order. Okay, whenever on benzene ring COOH is present, it is benzoic acid. OH group can be present as substituent. Their acidity order is ortho, irrespective of the group, ortho is more acidic. After that, at meta place only minus I, electron withdrawing effect is present, that's why meta we have to take in. After that, next we take standard condition, neither plus I nor minus I. Okay, but when you see para position, within the para position, electron donating capacity is having. So whenever electron donating is present, it's having less acidic nature. Okay, that's why if you write acidity order for this OH substituted group, you have to take in this, here ortho is first one and next one meta. After that, standard condition and least one is para. Okay, it is about OH group substituting benzoic acid. Okay, right, next. And after that, next we take another example. It is first example. In this example, we take OH as substitute on benzene ring. Okay, right. Now we take another group that is present on benzene ring. That can be taken as second example. Right. Now we see in second example, again we take standard acid. benzoic acid. It is standard one. Okay, without any group, it can be taken as standard. Now it write at ortho para meta positions. Right. You see, at ortho position, I take a group that is OCH3 or OMe, methoxy group. Okay, methoxy group can be taken as substituted. Okay, so it is orthomethoxy benzoic acid, and next we take at meta position metamethoxy benzoic acid, and in next example we taken at para position, so it is paramethoxy benzoic acid. Okay, so now we can explain about SDT of these four groups. Okay, so before explaining about this SDT, first we can see OCH3 group. OCH3 is having two natures. Okay, so whenever you see OCH3, according to inductive effect, it is a minus group, that means electron withdrawing group. According to mesomeric or according to resonance effect, it's having plus R group, electron donating group. Okay, right, whenever you see these groups on benzene ring, COH is presented is benzoic acid. In benzoic acid, irrespective of the group which is present at ortho position, always ortho compound is having highest acidic nature. So if you want to write SDT order for this, okay, here also ortho product is having highest acidity. It is according to ortho effect with irrespective of plus IE or minus IE, plus ME or minus ME. That means electron withdrawing group or electron donating group, any group it is present, acidity of this acid is highest for ortho. It is called ortho effect. Okay, right, ortho it's completed. Now we see meta position. At meta position again it's having minus IE nature. Okay, and but when you see para position, this OCH3 it's having plus RE, resonance effect. Okay, so here it can be act as electron donating, and here it can be act as electron withdrawing. So when you compare these two, it is more acidic, because the groups which are having electron withdrawing nature, that can increases the acidity. So here it can be act as electron withdrawing group, that's why it is more acidic than para. Okay, but in para, electron donating is present, but it is what? Standard. So when you compare standard and para, standard is more acidic than para. Okay, so if you write SDT order, this is the order. So if you take SDT order, ortho it is greater than meta, after that standard condition, and least one is para. Okay, in whenever you take para position, in para position OCH3, this group can be act as electron donating group. So whenever electron donating nature is present, it does not having SDT nature, that means it can be decreases the SDT nature. That's why when you compare these four compounds, this fourth group it having less electron withdrawing nature, that means it's having more electron donation nature, so it's having less SDT order. Okay, so it is an example. In this example, the substituted group we taken is OCH3, methoxy group can be taken as a substituted. Okay, right, and next we see another example. So on benzene ring, now in third example we can take another group. Right, so in third example we can take like this. Again benzoic acid, it is standard one. Now here the substituted group I taken is halogen. Okay, halogen group can be taken as a substitution in this. So that halogen group, it is present at ortho place. Bromine I taken ortho bromo benzoic acid, and in second condition, that bromine it is present at meta place, meta bromo benzoic acid, and in third position, that Br group it is present as para bromo benzoic acid. Okay, now you want to explain about in these four which is more acidic nature. Okay, so when you take COH, it is a standard benzoic acid, it is ortho, meta, and para bromo benzoic acid. Okay, so when you write about this SDT order, here the group present is Br. Okay, so whenever you take Br group, generally it's having minus IE nature. Okay, that means it's having electron withdrawing nature. Okay, it's having electron withdrawing nature. Okay, so when you write about minus IE nature of this bromine, the minus IE nature of bromine, it's present like this: ortho, meta, para. It is the order. Okay, so if you write these numbers 1, 2, 3, 4, right, in these four, minus IE nature is highest at ortho position, after that meta, and after that para. Okay, so if you write SDT order, if you want to write SDT order for this, we can write, so ortho it is highest one, so 2 is more acidic, after that meta, and after that para, and your standard one it is last one, because here all are minus IE group, all are electron withdrawing group. So whenever electron withdrawing group is present, it's having more acidic nature. In that condition, standard is having less acidic nature. Okay, so ortho, meta, para, after that standard one is present. Okay, it is acidity of halogen substituted benzoic acid. Okay, right. And next one, in place of halogen, now we take another group. Okay, see, in place of halogen, now we take another group, so that is NO2 group. NO2 group, it is nitro. Okay, now we are to take nitro group. Okay, so when you take nitro group, it is orthonitro-benzoic acid, metanitro-benzoic acid, and para-nitro-benzoic acid. Okay, here also you see, here NO2 group, it's having electron withdrawing nature. So electron withdrawing group is present, it's having more acidic nature. Okay, that's why here also same condition we can apply. 1 2 3 4, in this 4. Okay, if you write acidity order, although it is more acidic. Okay, that means second one it is more acidic, after that meta, and after that para, and least one. Okay, you see once here once, right? Listen, so when you say this, here acidity ortho effect, according to ortho effect, second one is more. Okay, and here see, it is meta and it is para. Okay, so here NO2 is electron withdrawing group, here NO2 it is also electron withdrawing group. But when you can see about NO2 group, when you compare it meta position and para position it's having more acidic than meta position. That means more electron withdrawing nature is present at para position when you compare with ortho. That's why in second place here para is present, after that meta, and least one is standard condition. Okay, it is acidity of NO2 group substituted benzoic acid. Okay, here NO2 group it is electron withdrawing group. So whenever electron withdrawing group is present, acidity can be increases. So here NO2 is present, by substituting by presenting this NO2, acidity is increases. So irrespective of the group, already we know that ortho group it is having highest acidity nature. So ortho is first one, and here metanitrobenzoic acid and paranitrobenzoic acid, in these two at para position more electron withdrawing capacity is present. That's why para is more acidic than meta, and after that last one is standard condition. Okay, so it is an example of NO2 group substituted benzoic acid. Okay, right. After that, and next we can see another example. Right, I take an example like this. You see, benzene ring. On benzene ring COOH is present, benzoic acid, and now I take NH2, amino benzoic acid, COOH NH2. It is ortho amino benzoic acid, and next we take COOH NH2, meta amino benzoic acid, and next we take COOH NH2, para amino benzoic acid. Okay, so when you see this, it is NH2 substituted amino benzoic acids. Okay, so whenever we take NH2 substituted amino benzoic acids, already we studied what we have to study here. Whenever benzoic acid is present, irrespective of the group which is present at ortho position, that is having more acidic nature. Already we studied like that. Okay, but when you see this, if you want to write acidity order of this, okay, if you write acidity order of this, okay, here what we have to write, we have to write here acidity order of these four groups. It is ortho, and it is meta, and it is para. Okay, so in these four groups, when we have to see, okay, in this ones, you see here I write like this, pKa values I take ortho 4.17. okay, right. And next you see meta, it having 4.79, para 4.92, and when you take ortho, it having 4.98. okay, these are pKa values. Okay, if you want to write pKa values for this benzoic acid, amino benzoic acid ortho, meta amino benzoic acid, and para amino benzoic acid, 4.17, 4.98, 4.79 and 4.92. Okay, so here you remember that the compound which is having a highest pKa value, that is having lowest acidic nature. Okay, so when you see here pKa value which is having highest pKa value, ortho group it is having highest pKa value, so according to that what you have to tell, it is weak acidic nature. Okay, so which is having more pKa and less pKa value, benzoic acid is having less pKa value, that means it is more acidic. After this meta, that is third one, 1 2 3 4 5. Okay, after one next third one, after third next we take fourth one, and in least one is second, that means ortho group, ortho amino benzoic acid, it is less acidic. Okay, so you remember this, it is an exceptional case. Okay, it is important and you remember this, it is an exceptional case. It is asking in examination because it is an exceptional case. Except this, in remaining condition what you studied, irrespective of the group which is present at ortho position, that is more acidic. But here ortho group containing amino group, ortho amino benzoic acid, it's having least acidic. So here that acidity we can explain according to pKa values. Okay, so the compound which is having highest pKa value, that's having less acidic nature, so it is an exceptional, we can remember this. Okay, right, these are some examples. In these examples you see we can explain about acidity by taking same group as